Hi everyone, I'm teacher Mandy. In this video, we're going to look at MGS Prelims 2022, Booklet B. I will only be going through the selected questions as they are more difficult. So for the easier questions, you can just look at the answer key and try on your own. It's quite self-explanatory. So please look at Methodist Girls Paper, Prelim 2022 and Booklet B. All right, this is how it looks like. Now, I will skip the first few questions and I will go straight to question 31 first. We're going to look at 31A. So here it is. Mr. Chin planted a potato plant. He removed an outer ring from the stem as shown below so that he could get bigger potatoes. So please underline these two words. Now we know that in the outer ring, it is actually the food carrying tubes. So as a result, the food carrying tubes were removed while the water carrying tubes remained in the stem. So it is still receiving water. So this is the image, a magnified view of the food carrying tubes that were removed. So they have part A, part B, part C, and here are the potatoes. They are underground. Question: at which part of the plant A, B, or C did Mr. Chin remove the outer ring from the stem so that bigger potatoes were produced? Explain your answer. 2-mark question. So first, you have to tell me which part. Is it A, B, or C? That will be 1 point. And the other point would be the explanation. Now, if you look at this, all right, in order to get the biggest potatoes, we would actually need as much food to be stored as possible. So because of this, all right, we would like to have as much food from the leaves being transported to the potatoes. Because of that, all right, the food carrying tubes that were removed were probably at part A. Because once you remove the food carrying tubes here, okay, the food that are made in most of the leaves will not be transported to the flowers. So where would they go? They will go to other parts of the plant. Of course, some would keep it for the leaves themselves, and some of it, or most of it, will actually be going to the stem and the underground parts, which is the roots and the potatoes. So the answer is, it is actually part A. The reason is because most of the leaves will be making food, and because of that, most of the food would be stored in the potatoes. So what are the keywords that you must have in your answer? You have to mention is A, part A. So reasoning, all the leaves or most of the leaves are below part A. So most food made in the leaves can be transported down and stored in the potatoes, making them bigger. Done. Now, let's go on to the next question. We're going to look at 32B. So this is actually a question on adaptations of animals. So animal A moves very slowly, so it's actually the snail. Its eye stalks allow it to see in any direction, and they will retract into the body when they are touched. So generally, it's a self-protecting mechanism protecting the eyes. Besides its eye stalks, its whole body can also retract inside the hard shell. I think this one is easy because usually we know it's a hiding place for it, so it can hide inside. I'm going to skip A because it's quite self-explanatory when you look at the answer key. Now look at B. Based on the above information, which is the information given over here, and of course the image that they have given to us as well, explain how animal A's structural adaptations help it to increase chances of survival. So as we know, adaptations is all about survival, all right? So here they tell us about 2 structural adaptations, which is the eye stalks and the whole body being able to retract. Now, the part about eye stalks is actually the difficult one because usually vision of humans is really we can just look mostly ahead. Of course, corner of the eye. But when we talk about allowing the eyes to see in any direction, we are talking about 360 degrees, and that is really good because you can watch out for danger. You can also, of course, look for food in that sense. But mostly in terms of survival, means not dying, we are mostly referring to getting away from predators so that you do not get eaten up by the predators. So when the eye stalks are able to see in all directions, it is able to look out for predators and escape. Okay. Of course, in times of danger, it can also retract its whole body inside the hard shell as protection. So what are the keywords that you need to have for this answer? So first, you have to mention the eye stalks allowing animal A to look around, spot its predators from all directions. Hard shell allows it to hide in it so as to protect itself from predators. Generally, it will not be eaten using these two ways of survival. Okay, now let's look at the next question. We're still on animal A. Now, animal A lives in a hot and dry environment. The graph below shows the temperature changes inside and outside its shell within a typical day. So, outside of the shell, which is the surroundings, it is actually at a higher temperature, in actual fact, much higher. This is maybe 40 plus, okay? Inside the shell, wow, it cools down by almost half a lot. You know, it's a half, it's quite a lot at noontime. So if this is about, let's say 35, inside might be around 20, 25, all right? So it's really cooling to stay inside the shell. Based on, again, it's based on the information given, based on the graph above, explain how animal A keeps itself cool. So generally, it's about retracting into the shell. However, beyond that, you also have to explain how does keeping itself inside the shell help to keep it cool. Okay, so how do we actually write out? Now, firstly, you have to mention that based on the information above, which is temperature inside the shell is lower than outside. All right, so it makes sense to hide, right? So hide inside the shell to reduce heat gain from the surrounding. So that's another keyword. And stay cool. So because of that, that's how it keeps itself cool. It is not just it's not just a protection mechanism. It is also to reduce heat gain because imagine it in this way, right? When you are outside walking in sunny Singapore, it's going to be really, really warm. But if you keep yourself in the aircon room, like in your bedroom, or try to stay in the shopping mall where there's aircon, generally you feel cooler, right? So it's the same idea. It's the same concept. So it's about reducing heat gain. Okay, now next we are going to look at 33B. So 33, all right, 33A is quite okay. Let's look at 33B. Now, Janet wants to investigate whether the presence of water, so if there is water versus no water, will help dead leaves to decompose faster. So if there is water, will it decompose faster? If there is lesser water, will it decompose slower? So she is given the following items for her investigation. She may use some or all of them. So she's given dead leaves, 200 grams, garden soil, 200 grams, water, 200 grams. She uses two identical containers and places them at the same location. State the items and quantity of items in each of the following setup. Now, we have the experimental setup, which is what we want to find out, and the control setup so that we can have a comparison. Firstly, how to do this question. Now, always think of what is the change variable. What is the factor that we are going to change? Usually the factor that we're going to change is the aim of the experiment, which is over here, in this case, it is whether having water will help dead leaves to decompose faster, which means, okay, one would have water and the other has no water. Only then will I know whether the leaves will decompose faster. So always remember, look out for the change variable. How to find out what's the change variable? Look for the aim of the experiment. Okay. Now, we are given 200 grams of dead leaves, 200 grams of garden soil, and water that's 200 grams. Okay. So if I need to have a fair test, all right, I should have the same quantity of dead leaves in each setup and the same amount of garden soil in each setup. Only water is different because that's the change variable. Okay, so one of them will have water, the other one will not have water. Which one will it be? So in the experimental setup, okay, we're going to have 100 grams of dead leaves and 100 grams of water. And then for the control setup, there's no water. All right, there's only the same 100 grams of dead leaves, same as the experimental setup. Now, how about garden soil? All right, I left it out so that you can think about it. Okay, do you need to have 100 grams of garden soil in the experimental setup and 100 grams of garden soil in the control setup? Yes, you need that. Okay, so let's put this in as well. So 100 grams of garden soil. Okay, and also 100 grams of garden soil, because the only difference would be water, the presence of water. And they should be the same quantity. That's why they mention quantity. That. Now, we are going to look at question 35, A, B, and C. So, Mrs. Raj placed a cube made of substance X and Y in the setup as shown below. So, we have X on the outside, Y on the inside, and this is a cooking pot with a heater. And there's a dish. There's a spout. Okay, all right. So substance X has a melting point of 52 degrees Celsius, means it will melt at 52. So I'm just going to write it down for my own reference. Always remember to do annotation, make some notes. And substance Y has a higher melting point. Okay, so substance Y probably melt with 60 degrees Celsius. It has to be above 52. Okay, now this makes things easier to answer question A. Mrs. Raj wanted to obtain a solid made of substance X only. So explain how she could use the above setup to do so. So she only wants X. Okay. Now, we do know that the melting point is at 52. So, and we know that there's a spout that goes into the dish. There's a heater. So all these are clues. Use each and every bit of information in the question to answer. So what we have here, we can actually heat it up first, okay? And we heat it up to 52 only. If you go higher than that, okay, you might melt Y as well, because Y has a higher melting point. But we don't know whether it's 53 or is it 60. So to play it very safe, all right, just heat up till 52 degrees Celsius. Melt X first. The melted liquid will have to flow somewhere. It will flow into the dish. Okay, and after that, we just wait for it to cool down. Or you can just put it into the freezer to make it even faster. So eventually, you will be able to get the solid that is made of substance X only. So what are the keywords that you need? Okay, so heat the cube to the melting point, or you can just mention 52 degrees Celsius. Becoming a liquid, flow into the basin, flow into the dish. Okay, and when it loses heat, it will just freeze to become a solid. Done. So these are the underlined words are the keywords you need to have to get the full 2 marks. Done. Now, next one, okay. I think I'll just go back to the previous one. Okay, so next question. At what temperature should Mrs. Raj set the heater to ensure that the solid does not contain substance Y? So as mentioned, substance Y has a higher melting point. So as long as it does not go higher than 52, because 52 is the one for X, Y has a higher. So anything above that, even 52.1, maybe its melting point. So just heat it at 52. It will not affect Y, because Y will not melt. It has a higher melting point, you need a higher temperature. So the answer is very simple. Okay, this one is actually just 52 degrees Celsius. Okay, now the last question is a little out of the blue. Based on the above information, again, is based on the above information, would you be able to tell the state of substance X at 120 degrees Celsius? Why? Well, over here, right, they only told us the melting point. It doesn't really give us any other information, like what happens after 52 degrees Celsius. So it can be a liquid, it can be a gas, or solid. We have no idea, right? So would I be able to tell? No. Based on the information there is, we are not able to tell. Now you're starting to see more and more of such questions in the PSLE exam. So do take note, all right? There will be answers like, no, I will not be able to tell. It will not be something like, yes, I will be able to tell. It is like English oral now, as long as the answer is reasonable, it is a valid answer. So do take note. Okay, now, but for science, we still need our science keywords, right? So firstly, you tell me no. Why? Boiling point is unknown. So you have to mention boiling point, which is the scientific keyword, and it is unknown. That. Now, let's go on to the next question, which is a very interesting question because of the story that it has. So 36. Okay, 36, I'm going to skip A because it's very easy. Now look at B and C. The diagram below shows the temperature inside Yu Xuan's house when the air conditioner was switched on. So inside the house, it's only 90 degrees Celsius. The glass window became foggy. It was fog, and she wrote the word love on it. Okay. How was she able to write the word, isn't it? The temperature outside is 32 degrees Celsius. It's a very warm day. Okay, so on her window, she was able to write the word love. Now, firstly, explain why it was fog. All right, that's 1 mark because in total it's a 2 mark question. So this 1 mark. Why was it fog? And was Yishan inside or outside the house when she wrote the word? So you're like, okay. Now, whenever you encounter questions on condensation, evaporation, or on heat and temperature, always think about, is it condensation? Is it evaporation first? What is the process that they are mentioning here? Over here, this is definitely a question on condensation. So when we talk about condensation, you have to think about 2 things. One, where is the warm water vapor? The next thing, where is the cooler surface? Because only when these two come together, then there is tiny water droplets. There is that mist, there is that fog, that white dust. Some of it call it white dust, right? Okay. So over here, okay, where is the warm water vapor? Which one has a higher temperature? Inside the house, outside the house? Outside the house. Because it's 32 degrees Celsius. Really warm. Okay. So that's where the warm water vapor is. Okay. And then where is the cooler surface? The cooler temperature, 19 degrees Celsius, which means the window inside, all right, is cool. All right. And this is where the cooler surface is. So the so-called formula, okay, or the golden keywords for condensation is warm water vapor coming into contact with the cooler surface of, over here is the glass window, forming tiny water droplets. And then the next question is, inside the house or was she outside the house? Just one thing about it. 10 seconds. All right. Now, what are the keywords? Firstly, she's outside the house. That's how she could get the warm water vapor to write on the cooler surface. Okay. So mention warm water vapor from where? Surrounding air, because it's really hot outside. Coming into contact with cooler surface, where glass window is the one with the cooler surface. Lost heat, condensed to form water droplets. That's how she was able to write LOVE. That. Now, let's look at the next one. because it doesn't stay there forever. The words will disappear actually. So after a while, the word love disappeared as shown below. So like this. Okay. Now the word love cannot be seen. Why? One mark. This is the new type of thinking questions that we have. If you have thinking math, now we're starting to see thinking science. If you have done the PSLE papers from the year 2020, 2021, 2022, you realize that there are a lot of thinking questions, isn't it? Okay, so learn how to do that. You will only see more and more because we want kids to be creative. We want kids to think critically. And we want to introduce the environment in school. And having you think through exam questions is one of the best ways to cultivate that. So start thinking critically. All right. Now, 10 seconds to think about it first. Why did it disappear? I'll give you a clue. Would there be more water droplets forming after a while? Let's say after 30 minutes. Okay, and think about how it's going to make the word disappear. Think about the link between these two and then write it down first. So give yourself 10 seconds. All right, now what happened? More water vapor condensed into water droplets. And due to gravity, the water droplets will fall down, right? Okay, it covered the word. That's why the word disappeared. It's all water droplets now. Right, interesting, huh? All right. So yeah, I find this a very interesting question out of the whole paper. Now let's look at the next question. Look at 37. We're going to look at A and B. Okay, so we have a circuit on the electricity chapter. Now, the diagram below shows the top view of Beth's toy house and a simplified circuit. Okay, so it's a dollhouse. A toy house, sorry. There is a light bulb and a switch in each room. Dun, 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 okay. All the circuit components are working. All right, so it looks very complicated, right? You have so many symbols here. You have batteries, right? You have wires. You have how many rooms? 4 rooms. Room 1, room 2, room 3, room 4. And then you have the bulbs, bulb 1, bulb 2, bulb 3, bulb 4. Okay. And a lot of switches. Switch 1. Where is switch 2? Switch 2, switch 3, and switch 4. Okay. Okay. Now, based on the diagram above, identify one disadvantage of the circuit. Well, I think the first thing is that it looks very complicated, but we can't have that as a scientific answer because it's just not scientific. It's just saying that it's complicated. So you need to give me keywords. In the electricity chapter, we focus a lot about the type of arrangement. So use the words parallel, series. Usually we're talking about this one. Okay, if everything is working, sometimes you can tell me answers like the bulb is faulty, the switches are not working, the batteries are not working, but this one all components are working. And we have to look for the disadvantage. So since everything is working, right, other than it looking very complicated, let's take a look. Is this a series circuit? Is this a parallel circuit? What do you think? Now, when you actually start to draw lines, right, so that you draw lines in this way so that all the switches are closed, okay, you do realize that it is very hard to just turn on like one switch and then you can have a lot of bulbs lighting up. Generally, okay, it seems to rely on one particular switch. Right, look at the diagram. Slowly you'll get one. Okay. Now, the disadvantage here is everything relies on that one switch, which is switch 4. So switch 4 must be closed so that all the bulbs can light up. If anything happens to that switch 4, let's say it's faulty, or it's just gone, you can light up the entire circuit, and then all the bulbs cannot light up. Then you can play with toy house. So this is a series circuit, and when you have a series circuit linking 4 bulbs together, you're too reliant on one particular switch, and that's very inconvenient. Yeah. So this is the disadvantage of this circuit. Next is the very fun one. Now, in order not to be reliant on that one switch, okay, she redesigned the circuit. So it's a redesign such that when any 2 switches are closed, 2 bulbs will light up and is with equal brightness. When all switches are closed, all the bulbs light up with equal brightness. Now, draw a circuit below to show how she will connect the 4 bulbs and 4 switches. They've already given us a very big clue. Equal brightness, whether it's for 2 switches with 2 bulbs or all switches with all bulbs. Equal brightness. Which type of circuit will give you equal brightness? Series or parallel? Parallel. Okay. Now, next thing is about drawing them. So since we need parallel, let's make it in such a way that all the switches and the bulbs are in parallel with each other. Okay. Now the part about any 2 switches are closed, 2 bulbs will light up with equal brightness. Generally, isn't it the same as when all switches are closed, all the bulbs light up with equal brightness? It's almost the same, isn't it? Okay, so just make it simple for yourself, all arrange in parallel, and that's how you're going to connect them. So looking at the light bulbs now, in a way they're arranged in parallel. I just have to draw the lines like this. Oh, sorry. I must make sure the connection is correct. So when you connect with the light bulb, one is to the casing, the other one is to the tip. Okay, so if I put it this way, you realize that they are all in parallel lines, and all I need to do is do this. So it's all parallel. But we want 4 switches. So now it's easier. Where do you place the switches? It's all parallel. I just have to ensure that, it's along here or here for this bulb, here, 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 here for bulb 1, 2, 3, 4. So depending on your preference, if you want to put it up here, hang on. If you want to put it up here, you can, but it's a very tight space. So I'm going to go for a space whereby, I have more freedom to put it in. So over for bulb 3, okay, I have more space to draw the switch here. For bulb 1, okay, I have more space to put the switch here. And for bulb 2, I have more space to put the switch here. So that's what I'm going to do. Now, always remember in the exam, use pencil first. Then once everything is done and checked and confirmed, then you can use pen to draw it in. All right. So let's say my switches. I'm gonna put it this way. Oh, it's a bit too far, right? So draw it closer. Yeah. Okay, and this one. All right. Oh, hang on. I'm overlapping into room 2 already. If my bulb 1 switch is here in room 2, then it's disastrous. So it's a bit too tight. So okay, I'm gonna change things here. So along the way, it might be you might have to make a few changes. So switch, like it will have to be here. We draw a smaller one, but it still has to be clear and able to be seen. So make sure your drawings are big enough in the answer. Oh, okay. This one I can't have it here because this is for bulb 2. Bulb 2 is in room 2. So my switch will have to be somewhere here. And done. All right. Where did that come from? Okay. And then double check, is everything connected properly? The batteries are connected properly. I'm connecting to the bulb, the casing and the tip, the casing and the tip, casing and the tip, the casing and the tip, and it's all good. Yep. Yep. So I have 4 switches. I have 1, 2, 3, 4 switches. 4 bulbs, 1, 2, 3, 4. They're all in parallel. Yep. Yep. I've done all checks. Let's take a look. Same. Yep. Okay, so always take note of the connection. And done. Let's go to 38C. That's the next one. All right, so question 38, I'm going to skip A and B. Go to C directly. So C is this part. Okay, we're looking here. So Mr. Lee then placed the same container, all right, with a wooden block inside. Okay, it's a difference there. At first, there's no wooden block. Okay, so now there is a wooden block. Okay, with a wooden block inside at the same position on the ramp as shown in diagram 2. We have a magnet fixed at the ramp, and then there's a container. Okay, now it's slid down. Now explain in terms of forces why the container slid down the ramp. Take note there's a magnet. Okay, now in the first part, okay, maybe I give you a little bit of background. In the first part, right, there's also a magnet, it's the same part. The only difference in C is that they added a wooden block. Now, and that it slid down. In the first situation, all right, it slid up, which means because of the magnet, it attracted this container. So this container is probably magnetic. Then why is it that since it's magnetic, it should be attracted to the magnet again? Why is it that after I added the wooden block, it doesn't attract? It fell. It slid down. And I have to explain in terms of forces. Don't be too worried when you see things like explain in terms of forces, explain in terms of energy, explain in terms of this and that. No need. Do not be too worried. Why? In actual fact, a lot of the answers that you give, right, explain why, explain how, you're already explaining in terms of forces, explaining in terms of adaptations, explaining in terms of this and that already. We're just not writing it into the question. So there's really no need to panic. Okay. So in terms of forces, right, of course, you must mention what are the forces involved. So firstly, what are the forces involved? Over here, we have magnetic force. But also take note there's gravitational force. Right? Is there friction? Yes, there is. Whenever you look at forces, right, always think, is there friction? Is there air resistance? Is there water resistance? Always take note of that because forces chapter, right, we tend to forget about the frictional force between them. So be very careful about this. Okay? So how do you write in terms of forces? Which means you need to have the word forces in your answer. How do you write it? Gravitational force acting on who, okay, or what, which is the container, greater than, we are comparing, THAN, greater than the frictional force and magnetic force between the magnet and container. So generally it's because the gravity is actually the weight. You guys will be like, oh, I know. The weight of the wooden block caused it to slip down. But that's not explaining in terms of forces. When you explain in terms of forces, you need to give me the terms like gravitational force, frictional force, magnetic force. So always remember you have to write it in this way. When they say explain in terms of forces. So your next question is, what if they don't have this? What if they just say explain why the container in diagram 2 slid down the ramp? Yes, then you can tell me, okay, the weight of the wooden block, okay, overcame the magnetic force between the magnet and the container. However, when I want you to explain in terms of forces, you must have the terms, the type of forces involved, like the gravitational force in this situation, and frictional force and magnetic force. Always remember that. It's a must. Okay, now, next question. We are going to the last question actually, all right, and that is question 40. So, it's question 14. This is a good one. Question 40. Amit wanted to find out which of the two springs, A or B of the same length, is safer to be used for the baby cradle. Now, a lot of you may not have seen this before. This is very old school. Very old. All right, baby cradle. Nowadays we have the electronic one. My baby niece was just using it when she was a baby. In the past, okay, during my time, maybe your parents' time, your grandparents' time, we were using this thing called the baby cradle. Okay, you know, babies, when you want to put them to sleep, it's not as easy as go and sleep, then they will sleep. No, you have to rock the baby, you know. But when you rock the baby for too long, your hands are tired. So we use this thing. Okay, so what we do is just to explain. Okay, this huge thing that takes up quite a lot of space actually. Okay, so you put the baby inside. This is made of cloth. Okay, put the baby inside, make the baby comfortable, and then you just pull it down maybe 3 times. And this spring will just continue to rock it up and down by itself. And the baby is like, oh, okay, slowly rock to sleep. Yeah, that's how it happens. Okay. Now, what happens if you pull too hard and the cloth falls to the ground? The baby is going to hit the floor. You never want that, right? Okay, this is what the question is trying to find out. Now, he's testing out which spring is more suitable. Because if you have a spring that's too loose, the moment you pull, it's going to hit the floor, right? Because it's too loose. But if it's too stiff, you try to pull, nothing moves. That's also a bad idea, right? Now, how does he find out? He's not going to put a baby yet. He's going to put various weights. One at a time, recorded the extension. Extension means the spring may just be, let's say, 20 cm. Okay. And if, let's say, he put a 1 kg weight, it goes all the way down to 30 cm. The extension is not 30 cm. The extension is 30 cm minus 20 cm, which means the spring extended by 10 cm. That's the extension. So you must take note of the term. Whenever you see a question that's on spring, think about, are they talking about the extension or is it the full thing? It's very different. Okay. So over here we have 2 springs. We have A and we have B. And he uses loads that are 1 kg, 2 kgs, 3 kgs, 4 kgs, 5 kgs. All right. We'll look at this in detail a little later. Now, based on the above information, which spring, A or B, is more suitable to be used for the cradle if Amit's newborn son weighs 3 kg? Explain your answer. So let's just check out the reading for 3 kg. Okay. 0, 1, 2, 3, 3 kg. So 3 kg for B, okay, it is at about 20, 30, 38, 35, okay. And then for spring A, it is at 60. 60. I thought we saw something like 60 somewhere. Yes, we did. 60. Now, this is the extended, which means if the spring itself originally is, let's say, 20. Okay, let's give it 10 cm. Let's give it 10 cm. Okay, let's give it 10 cm. Okay. A, okay, at 3 kg, when you put a 3 kg load inside, it will be 10 plus 60. 70 cm. Okay. B, when you put a 3 kg load inside, it would be 10 original plus the extension. Let's give it about 30, 36. An estimation. Okay, it would be 46. Now, 70 cm is this height, right? Is only 60. If it's 70, it's definitely hitting the floor. It's more than 60 already. It will hit the floor. You're not going to use A. The baby will die or get injured. But B is only at 46, so probably somewhere here. 46, maybe here. Okay, so it doesn't hit the ground at least, and it's still bouncing. So, which is more suitable? B. Problem. How do you explain this? They're like, okay. All right. Now, talk about extension. talk about over here, you don't really need to measure elastic spring force, you know. So just talk about extension, talk about whether it will hit the ground, and things like that. So 10 seconds to think about it. Time's up. How do you write? Now, use B. You have to use the word stiffer than A. Now, it is a comparison question. Which is better, A or B? Why? A is taller, B is shorter. A is this, B is that. Better than, taller than, higher than, blah, blah, blah. But you're going to need to give me the comparison. ER. Okay, so stiffer than A. So when the baby is 3 kg, spring B only extends to 40 cm. It will not hit the floor. You must tell me this part. It will not hit the floor. Okay, I repeat. You must tell me is B. You have to tell me stiffer than A. And it will not hit the floor. The part about extending to 40 cm is up to you. You can put it in or you can choose not to put it in because this will give you 2 marks already. This point, this point, this point. Okay? Yeah. The next one is even harder to explain. I think this is the real difficult one because the terms used, you have to come up with it on your own. Now, let's look at this one. Amit brought his elder son to the playground. Sorry, I teach English, so I'm a bit anal about this. To play on the spring horse. I'm sure you've seen this. The old and new playgrounds, they have this. Okay. When his son sat on it, the spring horse did not move much. So this spring is not very loose, right? Because it's very hard to move it. So suggest a reason. Now you're going to see a lot of questions that say suggest a reason, suggest, give a suggestion, suggest this, suggest that. Okay. This term suggest has been appearing in PSLE questions a lot in the past 3 years. Again, we're open to suggestions. So whatever is valid is correct. Of course, you have to use scientific terms, okay, or try to use scientific words as much as you can. So again, it's part of and getting students to think critically and be more innovative. Okay, so suggest a reason for his observation. Again, you have to suggest in terms of forces. So what do you have to mention? Over here, you have to tell me about the spring force, right? Okay. So we do know, I already mentioned, it is not very loose. That's why it's very hard to move the horse. If it is not loose, we can also say that it is quite stiff, stiffer, right? So stiff. So we can explain in terms of forces. It is stiff, and so it cannot move much. You can say that, all right? But you can also use another term that is very helpful in this situation. Now, the spring is very stiff and needs a greater load for more compression. And you're like, what about the elastic spring force? Okay. Now, in terms of forces, yes, you should mention like, is it magnetic force? Is it this force? Is it that force? Okay. But at the same time, other keywords will include using bigger loads, greater loads, work done, similar terms like that. Okay. Now, if you really want to add in elastic spring force, another way to write this is, okay, oops, not very clear. Increase the amount of load or weight. You can see that, okay? So there is more elastic spring force, okay, to move the horse. Or you can just end it here. Yeah. Another way to write it. Okay, that's why this is really the hardest question, I think, in the exam paper. And okay, so we've come to the end of this paper. All right, all the best for everyone's PSLE exam. All right. Always remember to check and use science keywords. You can also look at the science flashcards as a good revision before the exam. Quick and efficient. All right. So that's all, and I'll see you in the next video. Bye bye.